So we are dealing with keys, and we learned how to generate a key, a 128-bit key. And when we are asked to type our password in a typical PAN code, when entering our office, we're usually asked to insert 4 characters, only 4 characters, which are the password. They are 4 characters out of 10 possible characters, out of 0 to 9. If an attacker will try to brute force the password, he will have a key space of 10 to the power of 4. That is 10 optional characters to the power of the 4 that have been chosen as the password. In math, we call it a base 10. Quick math. There are 10,000 possible options. That is the key space that we are using. Only one out of 10,000 possible keys is the right password. Now let's take it to another area. Alphabet characters from A to Z. There are 26 characters. So when we use a password on our computer and we were asked to insert only 8 lowercase alphabet, no uppercase, no symbols, no numbers, only 8 lowercase alphabet, our key space is 26 to the power of 8, and that is a huge number. When we use binary digits, our base is 2. There is only 1 and 0. We are actually mapping 2 bits of input to the power of n bits output possible state. So if we had a key that is 2 to the power of 2, we have 4 possible keys, and that is with no permutations. If we take permutations, our key space is much larger. 2 to the power of 3, 8 possible keys. 2 to the power of 16, more than 65,000 keys, and so on. Today, we are not using anything that is less than 2 to the power of 128-bit, 256-bit, and 512-bit.